Okay, so we're going to talk about section 2.1 today. So section 2.1, it's about rectangular system, plugging the points, finding the distance, and finding the midpoint. Okay, so this is section 2.1. Okay, so 2.1, let's start with the first objective, which is plugging points. Then we'll talk about graphing equations, finding midpoint, using midpoint formula, finding distance, and use the distance formula. Okay. So first, you guys see the definition of ordered pair. That's just the point on the coordinate plane. Each point has an x value and y value. X is the first one, y is the second. So x, that's x values on the horizontal line, x-axis, y values on the vertical line, y-axis. Okay. So I will skip the definition. We'll just move straight to the problems. So example 1, we need to plot order pairs -2, 3, 0, 4, 2, 5, and 4, 6. So each order pair has a x coordinate and y coordinate. So we need to plug it in. So the coordinates of the point just give us the direction. Okay. I will just label each point. This is A. This one I will label with B, C, and D. So coordinate plane, X. Okay. On the X going to the right, coordinates are positive. Going to the left, coordinates are negative. Of course, right here it's 0. On the y-axis, going up, coordinates are positive. Going down, coordinates are negative. So point A, it's -2, 3. So I'm going to find -2 on the x-axis. Y coordinates equal 3. So I'm moving from -2 3 units up. And that's where we're going to have point A. Okay. Now, point B, coordinate 0, 4. So 0, it's right here. We have to find 4 on the y-axis. So this is B. C, we have point 2, 5. So find 2 on the x-axis, find 5 on the y-axis. So from 2, we're going 5 units up. That's where we're going to have point C. And the last point has coordinates 4, 6. X it's 4. And y it's 6. So this is 5, 6. So from 4 on the x-axis, we're going 6 units up, and that's where we have point D. And now I'm just going to describe it. So point A, -2, 3. So point A with coordinates -2, 3 is in quadrant 2. So like you see the coordinate plane, it's been divided into 4 pieces. Positive x-axis, positive y-axis, this is quadrant 1. Negative x-axis, positive y-axis, that will be quadrant 2, and that's where we have point A. Now, negative x-axis and negative y-axis, that's quadrant 3, and positive x-axis, negative y-axis, that will be quadrant 4. Okay, so we're going counterclockwise. So next we have point B, which has coordinates 0, 4. Okay, and point B, 0, 4, this is point B, it's on the y-axis. is on the y-axis. So B is on the y-axis. Now point C with coordinates 2, 5. It's positive x-axis, positive y-axis. So like you see, point C, it's in quadrant 1. And point D with coordinates 4, 6. The same thing, positive x, positive y. That means it must be in quadrant 1. So also quadrant 1. Okay. Next, what we're going to talk about in section 2.1, it's graphing equation by plugging points. So here we have to sketch the graph of y equal x squared. So I'm going to teach you how to graph this equation by using table of values. Okay. So we have table, we're going to create table of values. For x, you can pick any value you wanted. That's why here in the blue I wrote down that you have to choose arbitrary x value and solve for corresponding value of y. So x is independent variable, y depends on x. So for x, we're going to select any number we wanted. To evaluate y, we need to substitute x and bring that value to a second power. And the last table, that's going to be our order pairs, x comma y, which belongs to the equation y equal x squared. Okay. So first value which I'm going to select for x will be -2. So when x is equal -2, y is equal -2 to a second power. I substitute x with -2. Evaluate, we end up with 4. That means we have a point -2, 4, which belongs to the given equation. Next, let me select for x 1. So to evaluate the y coordinate when x equal 1, we're just going to replace x with 1. We're going to square it, and we're getting 1. So we have 0.1, 1. Next, I will select 0. It's always good to pick 0 for x. So y will be equal 0 to a second power, which is just 0. So we have 0.0, 0, which we call origin. Let's just pick 2 more. Next value which I will pick for x will be 1. So y will be equal 1 to a second power, and we're getting 1. So we have 0.1, 1. And one more, let's select 2. So y will be equal 2 to a second power, which is 4. We're getting 2, 4. So like you see, the values which I pick for x, I choose -2. Excuse me, this one should be -1. So I select -2, -1, 0, and then +1 and +2. Okay. So now I have a lot of points. So let's just plug them into the coordinate plane, and then we'll connect them, and that will give us the graph of the equation y equal x squared. Okay. So first point, it's -2, 4. -2, 4. Okay. Next point, I have -1, 1. Will be right here. Then I have 0, 0. Then I have 1, 1, 2, 4. And let's just graph it. And we get in parable. Okay. So you guys should notice that this graph is symmetric with respect to the y-axis. That's why when x was equal -2 and -1, you're getting the same value when x is equal to and +1, the same y value. That means this graph is symmetric with respect to the y-axis. So I plug in all the points and connect them, and we get the parabola. We'll talk a little more later about the graphs y equal x squared, which is the graphs of quadratic equations. Next part of section 2.1, it's a midpoint formula. So the midpoint of the line segment is just a point in the middle. And here, this is the midpoint formula, which you guys should know. So we have two given points, A and B. We describe the coordinates of point A with index 1. So we have x1, y1. And coordinates of point B with index 2. So that's x2, y2. To find the midpoint, technically what we're doing, we're taking the average of x coordinate and we take the average of y coordinates. Okay. So this is the situation. We have two given points, A and B, and we have to find the midpoint, like you see the point in the middle. So we will take the average of x coordinates, and that will give you x coordinate of the midpoint, and we will take the average of y coordinates, and that will give you the y coordinate of the midpoint. So let's practice. Let's do one example. Find the midpoint of a line segment using the midpoint formula. Okay, so here we have two given points. I'm going to label them. Negative 3, 2, that will be x1 and y1 from midpoint formula. 4, 6, that's the second point, so I'm going to label with x2, y2. And now we have to find the midpoint. So I will start with midpoint formula. Midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So that will give us the coordinates of the midpoint. So next we're going to substitute. So to get the midpoint, the x coordinates, x1 it's negative 3 plus x2, which is plus 4, divided by 2. Then y1, which is 2, plus y2, which is 6, and divide by 2. And simplify. And we're getting midpoint. So the midpoint, it's a point with coordinates negative 3 plus 4. This is 1. Divided by 2, it's 1/2. And the y coordinate of the midpoint will be 2 plus 6, which is 8, divided by 2. We're getting 4. Okay, so this is the midpoint. And we can quickly graph it. So I'm going to label the first point A and the second given point as a B. Let me see if I have space. So let me just try to graph it here. Okay, 1 and 1. So the given point, it was negative 3, 2. Negative 3, 2. That's that point A. The second point was 4, 6. 4, 6, right here. So this is point B, the second point. Okay, if we connect them, okay, so this is the line segment and the midpoint, which we just find. Midpoint has coordinates 1/2, 4, so this is 1/2, 4, 1, 2, 3, 4. Okay, so this is the midpoint, which we just find it, 1/2, 4. I'll just label with M. Okay, I think one example is enough of how to find the midpoint between two given points, the midpoint of the segment. And the last objective of section 2.1 is to calculate the distance. between two given points. So the distance between two given points, it's given by the square root x2 minus x1 to a second power plus y2 minus y1 to a second power. D stands for distance. A and B represents the two given points. The coordinates of the first point are labeled with x1, y1. The coordinates of the second point are labeled with x2 and y2. So also distance formula should be memorized. And we'll do one example. We need to find the distance between points A and B, and points A and B has given coordinates. So step number 1, copy distance formula. Next, you're going to label the coordinates of the first point as x1, y1, the coordinates of the second point, x2, y2. So next, we're going to substitute into the distance formula. So we have a distance will be equal x2, which is 4 minus x1, negative 1, and everything to a second power, plus y2, which is negative 5, minus y1, which is 5 square. And just don't forget to take the square root. And simplify. So next what we want to do, we want to combine like terms. So combine terms and simplify. So we have 4 plus 1, which is 5 to a second power, plus negative 5 minus 5, that will give us negative 10 to a second power. Now we're going to simplify. So we're getting 25 plus 100. And that will give us square root of 125. And now we want to simplify this radical. So 125 we can rewrite as 25 times 5. So this is the same as square root of 25 times square root of 5. And that will give us square root of 25, it's 5. So we're getting 5 square roots of 5. Okay. So this is the distance between point A and B. 5 square roots of 5 units. Okay, so that's it. This is the end of section 2.1. Hopefully that will help.